Good morning, students. Welcome to the class. I'm a faculty of physics on the behalf of IntelliLearn. My name is Mayank Ranjan Malvia, and in here IntelliLearn, we are going to learn physics like dreams. Okay, look, students. If you ever try to learn physics as a subject, it's my personal experience. It will be really a nightmare. Learn physics as an interest. Try to find physics around you, then it will be very easy for you, because there is one thing I must tell you, my friends, in the starting of the session, that 80% of the things which we are going to learn or study in the physics are not real. They are imaginary. Electric field, imaginary; magnetic field, imaginary; electric potential, imaginary. Lots of things are imagination. So you have to, if you go just by the book, it will be very difficult. So what we will try to do, we will try to learn physics around us, the world around us, because the world around us moves according to the laws of physics. Okay, so there is a very important term which I had just said, that laws of physics. And in laws of physics there are three laws which are the very basic laws discovered by Newton, law known as law of motion, known as laws of motion. Laws of motion. So starting to start this topic, laws of motion, first of all we have to understand what is motion. What is motion? And to understand motion, we have to understand what is rest. So there are these two terms, rest and motion, which we have to understand first to make a good and sound understanding about this chapter. Look, my dear students, these two terms are completely relative. Okay, just by the word using relative, don't think that they two are relatives to each other. No, these are relative, means they are not absolute. Absolute means which is true in every domain, which cannot be changed, is absolute. Like sun rises in the east, you are in USA, you are in India, you are in UK, you are in Japan, you are in Somalia, you are North Pole, North Pole situation changes, but here sun rises in the east, so that is an absolute fact. But here rest and motion, these two are not absolute, these two are relative. How relative? I am going to explain it to you. Please bear with me for some minute. Suppose that there is a road. Okay, everywhere you can find a road. Suppose that there is a road. Okay, and on the bank of the road, on the side of the road, there is a bus stand. Bus stand. Okay, and you with one of your friend to let them anonymous, I am naming them A and B. Two friends A and B are standing at the road and waiting for the bus. Bus is coming like this. Okay, this is your bus. Suppose that I'm not very good in arts, but suppose that this is bus. Okay, and their third friend, which is, we can see, which is C. Who is C? A third friend named C is standing in the bus. Okay, now, and bus is moving, driver is moving the bus. Okay, now just imagine the situation. A is looking at C. A is just looking at C. So if A is looking at C, then A will tell to his friend B, look B, bus is coming, and bus is coming means bus is moving. So for A, bus is moving. So the first interpretation is, for A, bus is moving. So if bus is moving, every object inside the bus is also moving. So for A, C will be moving. For A, I will write it much more clearly. So for A, C is moving. Similarly, then B will again look at C. If A tells to B, then B will look at C. Oh yeah, bus is moving. So for B, C is moving because bus is moving. Everything inside the bus is also moving. So C is moving. Now, this is situation number 1. Now bus comes to the spot, the bus stand, the bus stop, and now A is there because A came to drop off the B. A is standing at the bus stand, and now B goes inside the bus and sits beside C. Now initially what was happening, now B has been removed from here, so B is now not here. Now initially what was happening, for A C was moving, for B C was moving. Now B is inside the bus and now A is looking at B. So for A, now for A, second interpretation, for A, bus is still moving. That bus is moving, so B and C both are moving. So for A, B and C moving. Now it's turn for B. Now B will look at A. So for B, A is moving. How? For B, how A is moving? Suppose that you are sitting inside a train or a bus and bus is moving. Suppose that you are sitting and you are looking out of the window. So you will find all the plants, all the trees, all the poles, pillars, everything which was on the way or on the side of the road is moving backward. You will find that these things are moving backward. So similarly for B, A is also moving. Now for C, similarly A is moving. Okay. Now if C looks at B, what will C found? C is finding that the B is not moving for C. So for C, B is not moving means rest. Similarly, B will also found the same. For B, C is at rest. Now look at the same time. At the same time, for A, B and C both are moving, and for C, B is rest, and for B, C is rest. Means at the same time, for A, B and C are moving, and for C, B is at rest, and for B, C is at rest. So we can say that at the same time, B and C is at rest, and at the same time, B and C is moving. How is this possible? This is possible because the observer who is observing the whole thing, what we are doing here, we are writing observations. Observations are based on observer. So initially here A was observer, here also A was observer. So for A, B and C was moving. But as observers change, the situation also changes. So rest and motion depends on the frame of observer. What is the frame? Frame means, if we talk about frame, so frame doesn't means photo frame. In terms of physics, frame means there are two types of frame. One is inertial and second is non-inertial. We will talk about it later, inertial and non-inertial, but just frame, try to understand that the position in which an observer is. So rest and motion, these two terms is not absolute, they are relative and they depend on the position of observer. So rest and motion both are defined with respect to observer. So if we want to now, based on that data, based on that experiment, if we want to define rest or motion, so what will be the definition of motion? First thing, if I am going to define motion, so what will be the definition of motion? Let's see. Now again come back to here. Initially, for when A was there, A and B both were there and they are looking at C. So because bus is moving, so position of A is changing. Why? Because initially at some time when A started looking at bus was here. After time T, bus traveled that much distance, suppose that X, now bus is here. So what happens, for A, the position of C has changed. So A is saying that B is in motion. C is in motion. Similarly, if B is also inside the bus, for A, the position of B and C both are changing. Why? Because they are inside the bus and bus is moving. So for A, position of B as well as position of C is changing. So A is saying that B and C is in motion. So one thing is for sure, for a body to be in motion, their position must be changed. So first thing, motion, it is defined as the change in position, okay, and when position was changing, that time was also changing. Yes, time is also always unilaterally moving. Time is always moving in one straight direction. Time can never be backward. So it is defined as change in position with respect to time. Now again come back here. So for A, position of B and C was changing, but for B, position of C was not changing. So here an observer is also important. If observer is at different place, so observation can be different. So the position or definition of motion is, it is defined as the change in position with respect to time for an observer. For an observer, and this is the definition of motion. And what is rest? Rest, when they were in rest, when C was in rest with respect to B, when position of C is not changing with respect to B. So we can say that it is defined as if position of a body is not changing with respect to time for an observer. So this is the definition of rest and motion. If position of an object is changing with respect to time for an observer, the body is said to be in motion, and if this thing is not happening, body is said to be in rest. Like a simple example, you are sitting in a car, okay, and car is driving. So you are sitting on any seat, there are 5 seats, you are sitting on any seat. So if you are sitting, and suppose that you are taking steering as an object, so for you the position of steering, position means the distance between you and the steering, it is not changing. So for you, steering is at rest. But if a car is passing by and some person is sitting in the car and it is observing you, so just imagine this is your steering, a person is here, and as it is coming closer, the position of steering is changing for the observer who was sitting in another car. So for that person, that steering is in motion, but for you who are sitting in the same car, for you the position of steering is not changing. So for you, that steering is at rest. So a same object can be at rest or in motion at the same time for different observer. So this whole rest and motion phenomena is defined with the respect of frame of reference, in which frame the observer is observing. Understood? Now we have defined rest and motion. Now suppose that I am taking one more example. Suppose that you are sitting on earth. This is your earth. You are sitting on earth, and your another friend is sitting on the same plane, earth, okay. Now it is moon, and one astronaut is on the moon. So if you are looking at your friend, the position of your friend is not changing with respect to you. So for you, your friend is in rest, okay. But the person who is sitting at moon is, if somehow he is looking at you, so for this person your position is changing continuously. So for this person who is sitting on the moon, the position of A and B both are changing. So for him, A and B both are in motion, but for A, B is in rest, and for B, A is in rest. So you can clearly understand that this rest and motion phenomena is based on the relativeness, or we can say that the position of frame of reference of an observer. Now, so a simple thing, suppose that we are assuming that there is an stationary observer, always I'm supposing a stationary observer, and there is an object. This is an observer and this is a body. So for this observer, this body's position is not changing, so this body is in rest. Now suppose that you are standing at a ground, in a ground, okay, and there is a football in front of you. Football is at rest. You are looking at the football. The position of both the bodies are not changing, so for you football is in rest, okay. Now suddenly there is something comes to your mind and you go running to the football and kicked it. What will happen? As you kick the football, football will start moving, football will start flying, okay. It depends on the way you kicked it, that football will fly or roll. But suppose that it is not flying, it is rolling on the ground, okay. So now for you, the position of football is continuously changing. The position of football is continuously changing. So now the same football who was initially at rest for you, after applying a force, what you did? You just kicked. So when you kicked the football, what you did? You applied a force. So after applying a force, football start rolling and the position of football start changing with respect to you. So now the football is in motion with respect to you. So here is a very important point. Now, if we want to change the state of a body, from there are two states, one is motion and another is rest. So this rest is also known as static state, and motion is also known as dynamic state. So if you want to change the position or state of a body from static to dynamic, you need an external force. You need an external force. Lots of the students are still confused. What is if we have understood all the motion in kinematics, so what is the difference between kinematics and dynamics? The difference between kinematics and dynamics is that in kinematics we study only the motion, not the cause of the motion. Like here, motion is caused by an external force, okay. So in kinematics we will not study about the cause of the motion. We will study, okay, there is a motion, so there must be some velocity changing, so there must be some acceleration, the relation between velocity, acceleration, this, that and everything. In dynamics we will study about the cause of the motion or cause of the rest, means what is the cause by which the position of a body has changed. So what happened? You kick the football, football starts moving, and what will happen? After moving some time, after rolling some time, football will come to rest automatically. So what happened here? Here two things happen. First, initially it was at rest. After applying a force, it comes into motion, and again it comes into rest for you. So what happened here? Here there is a force who was responsible to change in its state from static to dynamic, and again there was a force of friction who was responsible to change its state from dynamic to static. It means if we want to change the state of a body, we need an external force. Without the application of that external force, the state of a body cannot be changed. The state of the body cannot be changed. Means if a body is in rest, it will be in rest. If you are not applying any force on it, the body will be in rest. Suppose that there is a stone on the side of the road. If nobody is applying a force on the stone, a stone will be there for lifetime. Or if a body is moving and there is no external force acting on the body will keep moving. Lots of the student will confuse here, sir, how is this possible? We kick a football and there is no force acting on the football, and after some time going some distance, the football will stop. Who is applying force? My dear students, there is a devil known as friction. Friction is applying force against the motion to stop it. Understood? Same experiment in space. If you apply a small force on a body, and the body will keep going and going and going unless you apply another force to stop that, okay. So if you want to change the state of a body from static to dynamic and dynamic to static, from static to dynamic and dynamic to static, from rest to motion or motion to rest, for both case we need a external force. If there is no external force, the position of the body cannot be changed. And this simple law is known as Newton's first law. So what does Newton's first law states? Newton's first law is also known as law of inertia. Law of inertia. What does this law of inertia states? The law of inertia states that if we want to change the position of any body from static to dynamic or dynamic to static, we need an external force. Without the help of an external force, we cannot change it. And what is this inertia? Inertia, various people on your level misunderstood it, inertia with mass. Inertia is not mass, but inertia is related with mass. Greater the mass, greater the inertia. What is inertia? Inertia is the property of a body by which it opposes the change applied to the body. Just try to understand. By which it opposes the change applied to the body. Means body was at rest and we push the body and body comes into motion. Now same thing, just imagine, in spite of football, in the place of football, I placed a stone of same size, a rock stone of same size. Now take it and you tell me, will that stone move? No, that stone will not move. Why it will not move? Because its mass is greater, and if its mass is greater, its inertia will be greater. So you need greater force to move that stone. You need greater force to move that stone. I hope you understand that phenomena. That same thing, suppose that a body, a small body, I think everybody have toys in their house. So there are some toys in which we tie a string and we pull it. So when you pull the toy and toy is coming towards you, you just apply a force like this and you can stop it. But suppose that at the same time, not that toy, a huge boulder is coming towards you rolling. Can you stop it just by applying a force by your leg? No. Why? Because boulder has greater mass, and if it has greater mass, its inertia is greater, so it will oppose more to the change. So what is inertia? Inertia is a property of a body by virtue of which it opposes the change caused to it. Means if we are trying to change the position of a body from rest to motion, its inertia will oppose it. Greater the inertia, greater the force is required to change its state. So what is law of inertia? Law of inertia says that if a body is at rest or in motion, body will tends to maintain its state unless and until an external force applied on it. That is your law of inertia. So I hope you understand this class. We will deal it in much detail, and I guarantee you will love physics. When you come here and start studying here, you will love physics. So that's for all for today. Thank you, class. Thank you so much.